All right, welcome. Before we jump in, just a quick heads up. This is part 4 of a 5-part tutorial from Virtualization Options LLC, and it's all for educational purposes, of course.
So, if you really want to get into the nitty-gritty, you should definitely check out the course PDF. It has way more detail than we can cover here. All right, with that said, today we are getting into some really advanced stuff. We're moving past the basics and right into the cutting edge of AI attacks, pulling straight from what's covered in Chapter 4.
In this question, man, it's a big one. You got to understand, AI security is this constant, non-stop arms race. While the good guys are building these massive digital walls, the attackers, they're not just looking for a ladder. No, they're evolving. They're cooking up totally new ways in that are faster, scarily realistic, and way more dangerous than anything we've had to deal with before. So the first huge jump, the first real game changer, was all about solving the realism problem. See, the early model inversion attacks, they were spooky, for sure, but the pictures they spat out were kind of meh. Just these blurry, averaged-out images that, honestly, you couldn't do much with. And this right here shows you just how massive that shift was. We're talking about going from a blurry, useless mess to something that looks like a real photograph. And the technology that made this happen? Generative Adversarial Networks, or GANs. They absolutely 100% changed the game. So how do they work? Well, instead of trying to build a face out of digital static, pixel by painful pixel, attackers now tap into the GAN's brain. Think of the GAN as having this giant encyclopedic knowledge of what real faces look like. So the attacker isn't guessing anymore. They're just steering the GAN through a gallery of already perfect faces to find the right one. It makes the whole process ridiculously efficient, and the results? Yeah, they're seriously convincing.
Okay, so that was GANs, but the evolution didn't stop there. The next step is, wow, it's even more clever. Attackers aren't just trying to beat the model anymore. Now they're actually using the model's own weaknesses against it.
So here's the dirty little secret about a lot of huge AI models. They don't just learn, they memorize. Like, they literally remember specific pictures and data points from their training. And this technique, MI overfitting, is all about exploiting that. It turns that memorization into a personal backdoor, letting an attacker just pull the original data right out. And the results are just staggering. I mean, look at this number. Using these techniques, researchers hit over 90% accuracy, pulling faces out of the huge Celeb A dataset. Let me be super clear here. We're not talking about pictures that kind of look like someone. We are talking about pulling out recognizable individual people. And just when you think it can't get any scarier, it does. These attacks aren't just crazy accurate, they're also 3 times faster than what came before. That means the time a defender has to even notice something is wrong and react, it basically shrinks to 0.
But really, the most important part is the quality of what's being stolen. The reconstructed images are so good, they keep over 85% of the original, key features. That's more than enough to identify the person again. That's a real, tangible threat to someone's privacy and their security.
All right, so now we get to the really big stuff, the absolute state of the art. Because attackers today, they're not just using one trick. Oh no, they're chaining multiple techniques together into these devastating multi-stage attacks. And you have to see this as a huge shift in their strategy. This isn't about brute force anymore. It's about surgical precision. It's about layering different attacks, one on top of the other, to cause the most damage. The best way to think about it is like a high-tech heist. The attacker doesn't just run in guns blazing. First, they do their homework. They use a technique called membership inference to confirm, hey, is John Doe's data even in the system? Once they get a yes, then they unleash the big guns, those powerful inversion attacks we just talked about, to pull out John Doe's specific data. It's smart, it's targeted, and yeah, it's terrifyingly effective.
So, what does all this mean for you? For the folks on the front lines, the security pros, the Pentesters, what's the takeaway here?
Well, the biggest takeaway is this. AI security isn't a set-it-and-forget-it kind of deal. It demands constant, and I mean constant vigilance. You have to think like the attacker. You have to anticipate these complex, multi-stage threats and build defenses that are just as complex. You need layers, defenses that can stop the entire attack chain, not just one little piece of it. Which, leaves us with this really tough question. In a world where attack chains are getting this complex, this sophisticated, can our defenses ever do more than just play catch-up? It's a sobering thought for sure,
And it's why we have to constantly be innovating, constantly researching, constantly testing. Not even to get ahead, but just to keep from falling behind.